In this video, we're going to go over the questions that were in your quiz. In the first one here, we have a pedigree that we're being shown, and we're asked about the mode of inheritance. Looking at this, I don't see anything in particular that would make me think that this is a recessive pedigree. In other words, I don't see any case where you have two parents that have perfectly normal conditions and then they have a child that does. And then just the contrast, if you look at any person that does have the disorder, when you look at them, in this video, we're going to go over the questions that were on your quiz. The first question here is asking you about the mode of inheritance that we're seeing in this pedigree. There isn't anything here that would indicate this is a recessive pedigree. If it were a recessive pedigree, we would expect to see at least one example where you have two parents that don't have the disorder and then suddenly a child that does. Just the opposite for any individuals that do have it, such as Caleb here, at least one parent does have it. And then Allie has a parent, Cord, that has it, and Cord has a parent, Jim, that has it. So the most likely mode here is going to be dominant. In question 2, we're asked to figure out the genotype of Jim. Well, since we said this is a dominant pedigree, that means that everybody that has the white color, they would be little a. And if I just mark some of those in here, Jim is colored in. So he has at least one capital A. If we consider that he has a child, Michael, that has two little a's, Michael must have inherited a little a from both parents. So this means that Jim must be heterozygous. In question 3, we're asked about Lily. We just indicated on the previous slide that, again, since this is a dominant pedigree, the white individuals would be recessive. So she is going to be little a. In question 4, we want to know which of the following individuals would be heterozygous, and we want to check all that apply. Well, we already indicated that Jim would be, so he's good here. If we look at the others, Luna, she is married. Luna is little a. Okay, so any of the recessive looking individuals, the white ones, are not going to be heterozygous. So she's out. So we know no on Luna. If we're looking at Ike, same situation. Edie is down here, same situation. And then Caleb, if we look at Caleb, Caleb has one parent that is little a, Drew, and then he has a parent that is capital A and something else. So we know that he has at least one capital A because he's colored in, and then he also would have inherited a little a from his dad, Drew. So Caleb would also be one that's heterozygous. So Jim and Caleb would be your answers on this one. On question 5, we want to know about Allie and Drew and the probability that if they have another child, that child's going to be affected. Okay, so Allie is heterozygous. Drew is little a. Okay, and keeping that in mind, if we draw the pedigree, or sorry, the Punnett square for these two, this would be my combinations. This is the Punnett square. Okay, so notice that affected is dominant, so that would be these two individuals here. That's 2 out of 4, or what would reduce down to 1/2. So 1/2 is the probability their next child will be affected by this trait. In question 6, we want to know what is the mode of inheritance on this particular pedigree. This one, if you look here, we've got a couple examples where you have two parents that don't have it, but then they have children that do. Another case over here, two parents that don't have it, a child that does. This is very characteristic of a recessive pedigree. In question 7, we're looking at the same pedigree, and we're wanting to know which individuals would be carriers. So carriers is going to be heterozygous. If we look down here, we can see that these individuals would be little a, all the ones that are colored in, and they have parents that would definitely be carriers. That's how they were able to have a child that actually had it. So we know that definitely number 2-1, 2-2, 2-3, and then, which is not shown in 2-4, they would definitely be carriers. Up at the top, one of these individuals would have to carry it, but we don't necessarily know which one. So we can't say that one of them must be. It could be number 1-1, it could be number 1-2. Okay, if we look at these over here, again, we don't know anything that's showing us that they must be a carrier. And then if we look at number 3(1) over here, again, there's nothing there that's kind of definitively telling me that that one could be a carrier either, because if you took these two parents, they can have children that are capital A, capital A. So we can't mark that one. If we had evidence of what that individual's children were, then we might be able to more definitively say if they were a carrier. The key here, though, for this question is we're talking about which ones must absolutely be carriers. And that's all we can identify in this particular example. Okay, in question 8, we want to know the genotype for number 3(4). And we want to know possible genotypes. Well, this is kind of what we just looked at for 3(1) over here. We know that these two individuals are heterozygous. And that's because they have children that are clearly affected. And these number 1 and 4, we know because they're dominant looking, they have at least one capital A. If we draw the Punnett square for their parents, here we can see that it is possible that those individuals, and this one in particular, because questions asking about that, they could be, they could be heterozygous, or they could be capital A, capital A. So both of these would be possible answer choices here. Looking at this one, we want to know the genotype for 3(5). This one is affected. It's definitely going to be a little a, because it's a recessive pedigree. Question 10, we want to know the most likely mode of inheritance. This one, we've got an example where you have two parents that don't have it. They have a child that does. Here's another child that does. This is very characteristic of a recessive pedigree. Here we want to know which of the following individuals must be carriers. Well, the ones at the top, these would definitely be carriers because they've got children that have it. This one here would have to be a carrier because they're able to also pass that on to their child. This one would have to be a carrier as well because they have a child that has it down below. These two would be carriers. They have a child that has it below. So keeping that in mind, we also can look at these individuals. They would, even though they look dominant, they inherited a little a from this parent. Okay, so they're carriers. Same thing applies to this one. And over here, these are really the only two that we can't definitively say because these two could be this or they could be this. And if you did the Punnett square from their parents, you would be able to see that those are combinations that do come up. So here, this one is a carrier, carrier, carrier. Number 2(5) is definitely a carrier. 3(1) is a carrier. And then these are the only two that we can't really say. They might be carriers, but there's nothing that definitively tells us that. On this one, we want to know the genotype for 3(4) right here. Okay, we kind of just answered that on the previous slide, but we know that this is a recessive pedigree. That means the white individuals are going to have at least one capital A. Given that this one has a parent that is little a, that one definitely passed on a little a to that individual. So this one is definitely going to be heterozygous.